Okay. All right. So do you understand this explanation?
Yes.
Okay. And then when you do this, the simplification of this, then you're going to have 12 root 3. Okay. Now equally, when you do a square root of 3 to the power of 4, that is the same as if you do now, right? Again, you know this is equal to 3. So the answer for this is just 9. Okay? So in here you're going to have 4. Okay, so you're going to have 4C4, which is 1. And then 1 multiplied by 9, so it's going to be 9. Okay. Right, so we got that. Let me get rid of this. Okay, and then we're going to simplify this. All right. Have a look. Can you see that I really want to have that structure? So I really want to have a number plus another number multiplying the square root of 3. So what I'm going to do, I'm going to put 1 and 9 together, which is, okay. So it's going to be 28. And then plus 4 and 12, which is 16. Right? Okay. Therefore we can say what? A is going to be equal to 28. And B is going to be equal to 16. That's it. Okay, so that. Now, I tell you this. These type of questions are very, very popular in tests. Okay, very, very popular. Sometimes, they are time consuming because the power is high. Okay, but sometimes we're going to give you something easy, let's say power equal 2 or 3. Okay? But if the power is, higher than 3, then you can do this and find the answer very, very quickly. Okay? All right. Damn. Now, I want you to copy the next heading. So, properties of coefficients. And then I want you to copy in the best possible way in your book. So you can see that between 2 is where the other one goes. So make sure that you do it, in the best possible way. So you do it in that way so then you can fit the coefficient in the right position.
So on the 2 one, is it 2C or 2 at the very end, or is it 2C?
This is 2C2, yes. Good point. Yeah. Okay, actually. Okay, so if you were here yesterday, you know exactly what these things mean. Okay? Do you remember this from yesterday?
Yeah.
Okay. Okay, so if you continue with this, you're gonna have this. And here I did it all the way up to 4. Okay, but then if you continue, up to some point where the power is a minus 1, then you're gonna have this. And then with the power equal to n, then you're gonna have this. Okay, so you can see here. In here we start from 0, 1, 2, 3, 4. Can you see that we are increasing the number by 1? Okay, so we go from 3 to 4. All right? Is that okay? Mm-hmm. Yeah, are you happy with that? Mm-hmm. Okay, now, if you continue, then you're going to have 5 C0, and then 6 C0, and so on. Okay, we're going to go all the way up to, n minus 1. Okay, so n could be, I don't know, let's say 100. Okay, so this is going to be 100 minus 1, and this is going to be the 100. Okay, but this is in abbreviated notation. So this is the same as, if you go from here to here, you are increasing this by 1, all right? Okay, so if you go from here to here, what are you doing? You are increasing this by 1. So the next one is going to be n. So if this is n minus 1, the other one is going to be n. And the next one, what is going to be the?
N plus 1.
N plus 1, and so on. Okay, but I stop in here, in these two lines, because from here we're going to do some property. Okay, first property. Property number 1. We're going to prove that nc0 is equal to ncn, and that is equal to 1. Okay, so that is very, very important. What we're saying is that the ends, the coefficient are always equal to 1. Okay, that's what we did yesterday. Remember when we did it in numbers? So we have 1, 1, 1 all the way. All right. Okay, the way that you're going to be proving this is to using the formula. Okay, so we're going to say recall. You already know that NCR is equal to n factorial. Okay, let's see how much you remember.
On n minus n.
N minus r factorial. R factorial. Okay, so that was the formula that we derived one day. Okay, so this is the formula that we're going to be using to prove these two things. Okay, so keep that in mind. All right, so we're going to prove these two things. Okay, let's do the first one. So we're going to say proof. Okay, so we are going to prove that NC0, so that means that it doesn't matter where you are in here. Okay, NC0 will be 1. Okay, so it's going to be one of the n's. 1. All right, so let's do it. So we're going to say NC0 equal. Now we're going to use the formula. So we're going to substitute n and 0 in here. Okay, so we're going to say that is going to be equal to n factorial divided by n minus 0 factorial multiplied by 0 factorial. Okay, so I did just a direct substitution into the formula. Okay, and then we're going to simplify. So on top we have n factorial. N minus 0 is just n, so it's going to be another n factorial. And then we already know that 0 factorial. One day I say that that is equal to 1. Okay, so that is equal to 1. And then you can see that the answer for this is just 1. Okay, so this will cancel that one out, so let me know the answer. Okay, so the first one is done. All right. And then we're going to prove that NCN is also equal to 1. Okay? So NCN is equal to, and then we're going to be using exactly the same formula. All right? So we're going to say n factorial divided by n minus n factorial, and then n factorial. Okay, and then you can clearly see that this will become n factorial. This is 0 factorial and n factorial. And then if you look carefully, that is also equal to 1. Okay? Too easy?
Too easy.
Too easy. All right. trying so. Okay, but the next property is not that simple. Okay, but it's still very, very easy to understand what is going on. Do you remember that this number here, for example, is the sum of these two? Okay, so I mean that this one is the sum of these two. Okay, and then if you look carefully here, when we did the n minus 1 and n, so we can see that this is the sum of these two. All right, so I want you to circle this. All right, so I want you to circle that. Well, it's not a circle, but I want you to just...
Just the full class, everyone did?
Yes. Yeah.
Catch you later on with the math medal. The math medal from last year. Yeah. Lucky. You missed out your way last. You were away when we gave it out. Was I?
Wow. Look at you.
It was fairly competitive there, guys, so for everyone.
Well done, Sean. Okay. Okay, so what we're going to prove, the next one that we're going to prove in the next video is this. So property 2. Okay, because this thing have to be proven, because somebody may say, okay, yeah, it's fine, it's working, but how do you know that it's going to work for all of them? Okay, you may say, oh yeah, you're lucky, it worked up to, 2000 C0, but how do you know that it worked for all of them? Okay, so this is how we're going to state it. So we're going to say, the next is NCK. Okay, so what we're saying is the next number is equal to the sum of the two previous ones from the previous row. Okay, so that is what we're going to be proving in the next video. So we're going to say NCK is equal to n minus 1 CK minus 1 plus n minus 1 CK. Okay, and this is going to be another very, very important property. Okay, so we're going to finish this video here. And on, when do we have maths again?
Tomorrow.
Okay, Friday we're going to prove this. Okay, so you can have a look. You can have a look at the proof of this beforehand. So when you come here and I do the proof, then you will understand. All right, so then we can finish the video now.
Don't forget to like, comment, and subscribe. Join my free gift card giveaway, giving out 1,000